Hey guys, so we've got a pretty exciting video today. We've been looking at drawing scatter plots, and we've been looking at these new bivariate relationships, so we have an x and a y variable. So today we're going to be looking at what is called Pearson's product moment correlation. Product moment coefficient, or we simply just call it the correlation coefficient. And it's denoted as efficient, and it's denoted as this r. So we just use this, a lowercase r, and this describes our correlation coefficient. So if we know, we've been looking at these scatter plots, and a scatter plot was basically, we had this axis, and then we had all this data, and we plotted that data, and we had this y variable and this x variable, and depending on how we plotted our data would depend on this relationship, and we've looked at describing them and other such things. So today we're going to look at assigning a quantitative just meaning a number value to these scatterplot relationships. So what I've got here is I've got a scale, and this is the Pearson's correlation coefficient scale. So this is the R scale, and in our R scale we've got between -1 and +1. So +1 means that the relationship we have, so our scatterplot relationship, is perfectly positively correlated. So it forms a perfect straight line where we have a positive direction and a strong relationship. It's not just strong, it's perfect. And this big -1 in red down here means we have a perfectly negative correlation coefficient, so this will form a negative relationship, and it'll be perfectly straight and linear. So the important thing is we've got linear. So this was a -1, and this one in green is a +1. And sort of anything in between represents these areas in between. So we can have a perfectly negative or a perfectly positive, or we could have anything in between. So we might have something loosely scattered, which would be sort of in between but still positive. So I'll draw this up on the axis just so that we've got an idea. So what I said was that anything perfectly positively correlated sort of formed this perfectly straight line, and it had a positive slope, it had a positive direction, so it's sloping up this way, and it falls on a perfectly straight line, so we can get one relationship to describe all of our data points. And then if we sort of come back to this 0.75, this just means that the relationship is weaker. So we've looked at describing relationships. Because the sign is positive, notice how we have positive numbers above 0, negative numbers below 0. If the number's above 0, this means that Pearson's correlation coefficient is positive. So an R of, say, 0.75 will mean that we have this positive slope, but it'll be more loosely scattered than if it was 1. So if it's 1, we've got a perfectly straight relationship. So this is R equals to 1, this is R equals to 0.75, this is R equals to 0.5, R equals to 0.25, R equals to 0, whoops. Then we have R equals to -0.25, R equals to -0.5, R equals -0.75, and R equals -1. So if we've got this R equals +1, it's a perfectly linear positive relationship. If R equals to, so this is perfect. This is a strong relationship at 0.75. So we've got this strong positive relationship. If we've got R equals to 0.5, so we're getting to more of a moderate relationship. So the data still goes up, and our scatterplot will still look loosely like it's going in this positive relationship, but it's more of a moderate relationship. If we've got an R equals to 0.5, we've got a weak relationship. So the data kind of indicates this weak linear relationship, but not so much. So R equals to 0.5, and we're looking at R equals to 0.25, sorry, we're looking at this weak linear relationship. And then when we hit 0, we get some pretty unique stuff happens. So if we're at 0, this basically means that there is, I'll take us down here, no linear relationship. So at 0, it means that our data, it could be perfectly positively correlated, but it might be a parabola, or it might be what's known as a cubic. It's not going to be a linear relationship. So if we have one of these perfect, say, U shapes, or these S shapes, or these W shapes, which are quadratics, sorry, not quadratics, power of 4, I forget what they're called. If we have one of these, it's not a linear relationship, even though it is a perfect relationship. Then kind of we can move down to this r equals to negative 0.25. And with this, it's sort of the exact opposite of our r equals to. Maybe not the exact opposite, but it is loosely the opposite of this r equals to 0.25. So this is our Pearson's correlation coefficient is negative 0.25. And remember up here I said that if we have a negative relationship in this red, we're going to have a negative sign out the front of our correlation coefficient. So all these red values have negative signs outside the front. This r here means that we have a weak negative value. So if the correlation coefficient is equal to negative 0.25, it means we have a weak negative relationship. Basically means that we're just going to see our data still loosely scattered, but instead of pointing upwards, the direction will be, say, more downwards, like this way. With our r is equal to negative 0.5, this is a moderate negative relationship. So we're kind of seeing our data is pretty loosely packed, but it's still sort of forming this downward direction. And again, if our r is equal to negative 0.75, we'll get a strong relationship, a strong negative relationship. So it'll be quite tightly packed, going in a downward direction, but it won't be perfect. And then with r equals to 1, this is when we have that perfect negative relationship. So we kind of see the data going down, and it's in a perfect straight line. So r equal to negative 1 is perfect. So that's what our correlation coefficient is. It's basically just a number, and it'll tell us exactly what kind of distribution, or exactly what kind of scatter plot we have. So if we've got r equals to positive 1, we've got a perfect positive relationship, and as our value reduces, the relationship gets weaker until it hits 0, where we have no linear relationship. Then we have a weak negative relationship at the correlation coefficient being equal to negative 0.25, and as we go down even closer to negative 1, we get this stronger relationship until we have a perfect negative relationship when the correlation coefficient's equal to negative 1. So I'm going to put some examples up which will clarify this, which will show you exactly how to use it and exactly what it looks like when we see this in practice. That's the concept. It should be straightforward enough. I hope to see you guys around for the next video. Cheers.